Hello and welcome to the Application 3 walkthrough for Integrated Math 1 for Upward Bound. Today we're going to take a look at some exponent properties and see like I said, the application type problems that we get from that. So just trying to be a quick walkthrough, not trying to do all the work, but maybe give you a little bit of a look at kind of a refresher at how to do some of these. So I'm going to leave number one. It's pretty straightforward. Deal with your numbers, numbers with numbers, and then like variables with like variables. So I would say the first thing you'll probably have is probably 30 from 5 times 6, and then you'll have some x's to some powers, and then y's to some power, and z's to some power. So not really much more that I can do on that one without actually giving away the problem. The thing that I want to do with number 2 is I'd like to break down the parentheses and at least get rid of those to where we can kind of be on the same page here. Keep in mind when I have a power outside of parentheses, that has to do with the power to the power idea, but we also have to distribute that exponent to the different things in the parentheses. So for this one, it's going to be 3 to the third, and then the power to the power rule multiplies my exponent, so I'll have a to the 6th. And then I'll have, in this one, I'll have 2, again, I have to think of 2 to the 2nd power, and then b to the 4 times 2. So 4 times 2 is 8. And then on the bottom, I'll have again 3 to the 3rd power from that 3 and that 3rd power. And then a to the 1st power times 3rd power. 1 times 3 is also 3. And then over here I just have a 2b, as there's nothing outside to raise any powers. And then what you're going to look at is, what can cancel out, what can use the quotient rule, those kind of things. I would say, really look at your A's, your 2's, and your B's. I think something interesting happens with these 3's out here. Okay, just look at one thing at a time, and it should go pretty well. The next set of problems, it's all about finding the area. So the area formulas might be helpful. Area formula for a rectangle is length times width, so you'd be looking at, what is 5 to the 3rd power times 5 to the 7th power. Now, obviously, maybe you think, well, 5 to the 7th, that's longer, that should be the length. That's okay. If you want to switch the order of those two, you're going to get the same thing in the end. The next one, we have the area of a triangle, so we have to go 1/2 times base times height. Okay, where my base is here, and my height is perpendicular to it. Great line there, but that's going to be my height. So I have my 1/2 base times height, so I'm going to have 1/2. Base is 4 to the 5th, and height is 4 to the 3rd. So I'll figure those out, and if you just want to leave it as a fraction with 1/2 in the denominator, that would be fine as well. Oops. Next, this is definitely the harder portion of this. It's about geometric probability, and basically what it says is if I had a dartboard that I was guaranteed when I threw a dart that I would hit at least this outer region, this outer rectangle. If I was guaranteed that the dart would hit this outer rectangle, what is the probability it would actually hit the inner rectangle? So all these steps, these three answers right here go to this one problem. Okay? So it's all to figure out this one problem. And so yeah, the way we look at that is we would look at what is the area of the shaded region? Well, it's a rectangle. Actually, it's a square. It's 3 times 3, which is 9. The entire region, the outer region is 8 by 14, which is I think 112. Let me double check that. Yeah, 112. So 112. And that means the area, or the probability of landing in the shaded region is the area of the shaded region, 9, divided by 112. In this one, we can get a decimal answer. That's okay. 0.08. Let's just round it to that. So that one didn't really deal with much exponent, any exponent properties or anything like that. But these ones will. So let's go ahead and take a look at the second one, and then I'll leave the third one for you. For this one, the area of the shaded region is going to be x times 2x. And just to leave you a little bit of work, I'm going to leave it as this. I'm going to let you go ahead and tell me what that equals. Again, I don't want to do all of this. I just want to get you on the right track. Area of the entire region, we have 6x and 3x. And then you're going to take those two answers and put the shaded region on top. Whatever you get here goes on top. And whatever you get as an answer here will go on the bottom. And that'll be your probability. And you can try to reduce it. Maybe leave that one as a fraction. I think it would be a little bit easier. And then the last one, the only other thing you need is the area of the circle formula. And that's going to make it, a little bit cumbersome. It's going to make it a little bit difficult, but it'll be okay. The big thing you want to know is that this r is the radius, and the radius is the measurement from the center to the edge. So if the radius is, if the whole stretch here is 4x, this radius is actually going to be 2x. So in finding the area of the shaded region, it is a circle. I know it looks kind of squished on there, but it's going to be pi times the radius squared. We just said the radius was 2x. And so we have to take that 2x and square it. In which case, I'm actually going to put the pi right after the number, but I'm going to get 2 to the second power times pi times x to the second power. No real reason to put that pi there other than just normal conventions. That's just the way that we typically write that. Okay, and then the entire region is going to be the 4x times the 3x squared, and you can go ahead and see what happens there and where, what your probability would actually end up being. It might not be just a nice round number, might not be a number at all. You might have a variable in there, but just give that a shot. So that'll be it for the application number 3. Again, if you have any questions, feel free to ask them in class, and have a good day.